Good morning, class. The session is being recorded, and therefore, again, as always, if there is an issue of privacy, please make sure your audio video is muted. Make sure there is nothing in chat that you put in. Make sure you do not participate if I ask you a question. Also, change your name to your initials if there is a privacy issue. This is being recorded and will be posted for your fellow students. Section 3.2. The derivatives as a function. All right, so we've already looked at the derivative and rates of change using the definition at a specific point. Now we want to write it as a function and generalize it. So just to refresh your memory as far as what we covered quickly, first, we discussed the slope of a line, rise over run. The way you calculate, it's very simple, rise over run, and depending on how you write that, if the first point is at A, therefore the pair is A f of A. If the second point is at X, it's X f of X, it gives rise to this. And this is the way you calculate the slope, rise over run. However, if we change that to the following, if the first one is A and then we go H to the right, this gives rise to the second point having X coordinate A plus H, and the pair would be A plus H and F of A plus H. This will give rise to this equation. Okay. And of course, if I change this one, let's say to B, then it gives rise to this equation. All of them are the same, everybody. All of them are rise over run. All of them are referring to the slope of a tangent line. So what happens is that this is a secant line, and if we move this Q and get it closer and closer to P, eventually in a limit sense, it becomes the tangent line, and therefore we get to the slope of a tangent line at point P. So we define that M of tangent line is the limit of M of PQ, this line PQ, which is a secant line as Q approaches P. Or if you go with the first definition as X approaches A, if the middle one as H approaches U. This gives rise to the equation of a tangent line. As I mentioned, you don't have to memorize that. It is simply the point slope. Y minus Y1 equals M times X minus X of 1. And we have this definition for F prime of A. Now, what we are going to do, we are going to look at the same thing. And if you recall a couple of questions towards the end, I kept the A as A instead of a specific number that was given. And that really is the same as saying, okay, I keep it as X. What is the difference? When you fix it at A, it becomes the slope of a tangent line at A. When you generalize it, we call it the derivative function. And this represents the slope at one point, X equals A. This represents infinitely many, okay? And what is the advantage of this? If I want to come up with the equation of a tangent line at one point, perhaps doesn't make that much of a difference. But if I want to evaluate it at several points, then instead of going through this and evaluate it again one by one, I just evaluate the general and then plug in those points. F prime of A, let's say A is 5, so F prime of 5. F prime, let's say, is 10, F prime of 10, so on and so on. All right. There are various ways of using this notation. All of them refer to the same concept known as differentiation. Y equals F of X, okay? We normally use F prime of X or Y prime. This is the notation, Y prime or F prime of X. This notation, known as Leibniz notation, is also common, dy dx, dy dx. There are others we don't come across often, but at least I want you to be, exposed to them. So df dx, d dx of f of x, capital D f of x, or d sub x sub f of x. When you write it in this format, you are telling your reader what is your independent variable. What is it that you're taking the derivative with respect to, namely x. So the symbol capital D or ddx are what we call differentiation operators, okay? Because they indicate the operation of what? Differentiation, okay? We can rewrite the definition of derivative in Leibniz's notation in the following form. Check this out. dy dx is the limit of delta y over delta x as delta x approaches 0. If you recall, delta x was that distance we called h, okay? So dy dx is the limit of delta y over delta x as delta x approaches 0. Finally, a function is differentiable at a if f prime of a exists. Okay, fine, it makes sense. But it is differentiable in an interval, open interval of a to b, because the endpoint is a different story. If it is differentiable at every point in that interval. So a function is differentiable at a if f prime of a exists. What if we are discussing an interval? It is if it's differentiable at every point of that interval, and that's extremely important to understand. Let's look at the example that we basically have seen before, what we want to have a fresh approach here. We've seen this type of question before, coming up with the equation of a tangent line. We know how to do that. In order to do that, we need two things. We need a pair and we need a slope. Before we continue to find the slope, can anybody tell me what pair, because I only see x equals 8. So what pair is that? Is that given? How do you come up with that? In other words, what I'm saying is that, okay, we know 8. What is the y coordinate? Anybody?
You have to plug it in to the function.
Perfect. 3 times 8, 24, plus 1 is 25, square root of that. So we got the y coordinate. And that's the idea I want you to be very careful of. They don't have to give us a pair. As long as they give us the x, we can figure out the pair. Okay, that's good. The next thing is we want to find the equation of a tangent line. Now, to find the equation of a tangent line, by the method of the previous section, we would find f prime of 8. By the method of this section, we're going to find f prime of x first, and whenever we are done, we replace it with, we replace the x with 8, and that's exactly what's going to happen now. So the very first thing is writing this definition. If I can write this definition, practically I'm done, okay? Because that's the hardest part, believe it or not. So we are going to write f prime of x is the limit as h approaches 0, fraction bar, the denominator is h. Now f of x plus h, that means replace the x with x plus h, and then minus f of x. So take a look. It's that simple. What is f of x plus h? So 3 times x plus h plus 1. This is f of x plus h. F of x is simple, it's there, and you're done with the first step. Obviously, it's clear that if you plug in, you get 0 over 0. So we need to use our technique to fix the problem. The technique was to do what? We would do what to take care of the problem, class? Because the problem is 0 over 0, indeterminate form, right?
Multiply by the conjugate.
Beautiful. Which means you write both of them unchanged. You just change this negative sign to a positive sign. These two don't change. Okay? So you put it at top as well as the bottom. Why? Because this whole thing, everybody, this thing is equal to 1. So you're multiplying by 1. You're not changing anything. But the process will give you the answer. Of course, the denominator, you do not touch it. You write it as a product. What happens to the numerator? A minus b times a plus b becomes a squared. This guy comes out. So you drop the square root sign minus b squared, you drop the square root sign for the second piece. So take a look. The denominator we don't touch, okay? We write it as a product. And so what happens? All you have to do, simplify the numerator. So let's do that. So this is 3x plus 3h plus 1. This is minus 3x minus 1. 3x, negative 3x cancel each other. Positive and negative 1 cancel each other. So we are left with 3h in the numerator. And as you can see, h drops clearly. You are left with number 3 in the numerator. Okay, so let's see what happens now. We are dealing with the limit as h approaches 0 of 3 over this mess. Finally, there is nothing else we can do. We plug in h. If you replace the h with 0, I hope you realize the first and the second square root become identical. Both of them become square root of 3x plus 1. So you have 2 of that. And that is f prime of x. Okay, everybody? That is f prime of x. Okay. Now we want the slope. This is not the slope yet. What is the slope? Plug in 8 and becomes the slope of a tangent line at x equals 8. So if I plug in 8, f prime of 8, I get 3 over 10. Why is that? Okay, let's plug in. If you plug in 8, 3 times 8, 24 plus 1, 25. We said this is 5, right? 2 times 5 is 10, 3 over 10. So f prime of it is 3 over 10. I'm assuming everybody can do this. Plug in, you get 3 over 10. We have the slope. We have the pair. All we have to do, y minus y1 equals m times x minus x sub 1. So y minus 5 equals 3 over 10x minus 8. Now I want to just quickly show you that you get, okay, so over here, you get y minus 5 is 3 over 10 x minus, let's just say the 24 over 10. Now 24 over 10 is 12 over 5. So minus 12 over 5 and positive 5 give us 13 over 5. Okay, that's the final answer. So y equals 3 over 10x plus 13 over 5. So I hope everybody is clear. Okay. All right, let's move on. So we looked at an example that we had seen before, but with a different approach. Okay, the next thing we want to discuss, the graph of a function is given. Can we come up with the graph of f prime of x? And so to do that, there are some important, information we need to have. Notice those points, peaks and valleys, if we were to draw a tangent line would be horizontal, the slope of a horizontal line is 0. So those points correspond to 0 on the x-axis, okay, class? Also, remember, so the relative max and mean occur at the peaks and valleys, and that's where f prime is 0. You have a horizontal tangent line. And remember, when f prime is the concept of increasing, f prime is positive, the function is increasing. f prime is negative, the function is decreasing. But I want to refresh your memory as far as increasing, decreasing. Increasing, think of a positive slope for a line. Decreasing, think of a negative slope for a line. This was the basic definition in pre-calculus. X goes up, X gets larger, so does Y. That is an increasing function. X goes up, but Y goes down, that's a decreasing function. And again, a simple example, class, if you happen to have a line with a positive slope, right, class? Everybody remembers that? And a line with a negative slope, okay? So let's see how we are going to graph this. First, pay attention to those points that we mentioned, A, B, C. So take a look. I want you to ignore that for now. So they correspond to 0. So you graph zeros for those, okay? And what about the other ones? You have to figure out if they are positive, they have a increasing format or decreasing format, okay? So this corresponds to 0, this corresponds to 0, this corresponds to 0. To the left of A, everybody, to the left of A, it's what? Decreasing. This portion, decreasing. F prime is negative, and therefore is below the x-axis. So is this portion. This portion, increasing, and f prime is positive. Okay, so when you want to graph that, if actually I'll try to do something at top because I want to leave the bottom for a better graph. So roughly, this is not to scale by any means. This corresponds to 0. This corresponds to 0. This corresponds to 0. So take a look at those. And then to the left of this point, we said it's decreasing, so it's below the x-axis. I hope you see that it's below the x-axis. Again, it doesn't have to be perfect. It's a rough sketch. But what happens between A and B? Between A and B, it's increasing. So between A and B is positive, so it's above the x-axis. But at A, it's 0, at B is 0. So when it goes up, it has to come back down. Okay, goes up and comes back down. Here to here, decreasing. So here to here, below the x-axis, but at B is 0, at C is 0. So it's below the x-axis and it has to come back up. It's below, but it has to come back up. And then at this point is 0, but this portion is what? Increasing, so from there on it goes up. And again, just continues going up. Okay, so I want you to pay attention to this graph, which is more detailed. The thing I want to explain is this point and how they arrived at it, because it's important to see how it's done and what is the purpose of that. So A corresponding to A prime, B to B prime, C to C prime, and to the left of A, okay, decreasing below the x-axis, between A and B, increasing, but it has to come back down. Between B and C is decreasing below the x-axis, it has to come back up, then it continues. The idea is that pick any point you want and do your best to draw a line, a tangent line, and then you pick up 2 points on that line segment and calculate the slope. They have done that. So at this point seems to be at x equals 5, the slope is 3 halves. Therefore, corresponding to f prime, we have 5 comma 3 halves or 1.5. That is the purpose of that. Do you have to do that? By no means, but that's the concept. Okay, class? Okay. Let's start with the simplest example we can come up with to draw a derivative function. If you happen to have a line, everybody, okay, how do you draw a tangent line? Just y equals the slope. That's all. Because remember, the lines have equations y equals mx plus b. Okay, let me just actually draw this and then erase it right here. So class, in general, y equals mx plus b is the equation of a line, and y prime has the equation m. If the line happen to be a horizontal line, okay, any horizontal line, the slope is 0. So the equation is y equals 0, or the x-axis. But if the line is not horizontal, let's just, make something up. So this one, y equals mx plus b, then the slope is simply a horizontal line having the equation y equals m. And that, I hope, is clear to everybody. With that being the case, all you have to do, calculate the slope here. And I hope you see that this is 0, 0, and this one is 1, 3. They have different scales. The slope m equals 3, so y equals 3. Let me just erase this now. We don't need that. Okay, everybody. Is the answer. Very simple. Okay. How about this one? Again, you want to look at important parts. Okay. So if we were to graph the important parts, this corresponds to 0. This corresponds to 0. Okay. And over here, okay, f prime, it's increasing, right? F prime is positive, and that means above the x-axis. Okay, that means basically above the x-axis. So I'm going to graph it and erase it. Okay, so it's above the x-axis. This portion in red, f prime is negative because it's decreasing. So it's below the x-axis, but it has to come back up. And then again, f prime is positive because it's increasing. So it basically continues. That's the graph. I hope everybody's clear on that. So let's make it look good by erasing this and look at a better graph. Those are the 2 points corresponding to the 2 points here. And there you have the graph. Again, pretty straightforward, everybody. Here's another example. So take a look. What do we notice? This portion increasing, f prime is positive, so above the x-axis, this portion is decreasing, f prime is negative below the x-axis. At this point, we have a horizontal tangent line. It's looking like this. I hope everybody is comfortable with that. Okay, comfortable. All right. The next topic, where a function fails to be differentiable. There are three ways. When we have a sharp corner, okay, in other words, if you were to draw a tangent line, how would you draw it? And the limit on both sides are not the same. If you have a discontinuity, or if you have a vertical tangent line, if you recall in the case of a vertical line, the slope is undefined because it really tends infinity or negative infinity. There's more to this. As far as we're concerned, this is good enough. So I'm going to quickly recap each one. A corner or kink, the graph of f has no tangent line at this point. The left and right limits are different, left side and right side. If f is not continuous, then it's not differentiable at a. So at any discontinuity, this is an example of a jump. It is not differentiable. I have this posted. Okay, you don't have to worry about that. In the case of a vertical tangent line, the limit of f prime of s as x approaches it, it's infinity in the absolute value sense, meaning either from both sides we go to negative or positive infinity. That's a more precise definition. Again, you don't have to worry about that. There is a little bit more to it. I will explain it here. In this case, some people mix it up with this. Some people even mix it up with this. What happens is that the limit from both sides, they go to infinity. One goes to infinity, one goes to negative infinity, and they call it a cusp. Again, you don't have to worry about that. This is a little bit more technical. We cover that in calculus. You don't have to worry about that. But as long as you recognize a sharp corner, discontinuity, a vertical tangent line, you're fine. Here's a simple example. I don't think anybody's going to have any problem figuring out what's going on. We want to see where function, fails to be differentiable. If you look at the first graph, clearly at x equals 0, we have discontinuity. So that's very straightforward. Fine. Also, look at this point. Okay, if you call this a sharp corner, I'm okay with that. But it is really a vertical tangent line. And how do we know that? Give me a second and I'll explain it to you as soon as we are done with the second graph, because I want to compare and contrast. So if I'm looking at the second graph, okay, it fails to be differentiable here at -1 because there's a discontinuity. Also, it fails at 2 because it's sharp corner. Let me just give you that, and then let's compare and contrast. I hope you realize that it is clearly sharp corner because it almost looks like a V shape. So if it looks like class, if it looks like a V shape or an upside down V shape, and it's fairly clear, that is a sharp corner. However, in this case, it seems to be going up if we were to continue. Do you follow what I'm saying? Whereas this one goes this way, one goes that way, okay? So that's the idea that I think separates the sharp corner from a vertical tangent line. Again, as far as I'm concerned, If you mix them up, I have no problem with that. The sharp corner is clear. If you are having difficulty with the vertical tangent line and you say it's a sharp corner, that is absolutely fine with. All right. In this topic, as far as the graph is concerned, let's look at one more example, class. Let's look at one more example regarding this matter. We want a graph f prime given f. So what I'd like you to see is the following. We have 1, 2, 3, 4 line segments. Also, I want you to notice these are all sharp corners. Okay, which means sharp corners result in a hole. Okay, why? Because it's not differentiable. Remember that. Okay, now if you look at this one and this one only and assume there is nothing else, if it continued indefinitely and if it doesn't, then you would think it's a line. You calculate the slope and you would draw a horizontal line equal to this slope. Same thing for this guy, same thing for this guy, same thing for this guy. For each piece, if you figured it's a line, that's what happens. Okay. So the very first thing we want to do, let's look at each line segment and calculate the slope. To calculate the slope, let's come up with the pairs. Assume these are the pairs, and if you have a different reading, I have no quarrel with that. So this is at -3, 1. This is at -1, 0, clearly. 0, 1, 1, 0, 3, 1. So you want to calculate the slope for this. So I'm going to quickly refresh your memory about the formula, and the formula was, okay, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that would give us 0 minus 1 over minus 1 minus -3, which gives you -1 over 2. So that is the slope for this guy. And by the way, you may see that or not, this one has the same slope but positive, so this becomes +1/2, okay? This one, clearly the slope can be calculated as 1. And if this is 1, this one is -1. So first thing first, calculate the slopes. We calculated 4 different slopes for 4 different line segments. Okay, now remember this one stops at -1. Okay, so if you were to, I'm going to do that, and I'm going to erase it in a moment because, you know, so understand that this is 1, this is 0, this is 1. So for example, to the left of this, we are dealing with this one, okay? So to the left of this, we have to graph the line y equals -1/2. So I'm going to just graph that one. So I would have, if this is -1, oh boy. This is y equal to -1/2. I just want to look at one piece, okay? If this line continued indefinitely on both sides, the answer would be this line, but it doesn't. It stops at -1. So I'm going to stop at -1. How? I need a hole here, and I'm going to get rid of everything to the right. Do you see that? You do the same thing with the rest of it. And that's how it works. So let me just erase this because I want to show you the proper answer. Okay, so y equals -1/2 for this one. Y equals 1 for the second part. Y equals -1 for the third part. Y equals 1/2 for the last part. This one, as I mentioned, from here on, This one just between -1 and 0 and you have a hole. This one between 0 and 1 and you have a hole. And this one from 1 on. So take a look. So again, as an example, this line, this is this loop. Do you see that? This line, this is the answer. So I hope you can see that. Okay, so I hope it's clear to everybody. All right. Let's differentiate using definition for these examples. And in the next section, this will happen just in a split second using differentiation formulas. Okay, I want you to know that. But for now, let's see how we deal with it. First and foremost, we write the definition here. For this one, the f prime of x is the limit as h approaches 0, f of x plus h minus f of x over h. So we are using this. What is f of x plus h? 5 times x plus h plus 1 minus, and you can write the f of x. So believe it or not, if you write the first step and you can simplify, you're practically done. I can't emphasize this enough. As long as you can write the first step, the rest should be a piece of cake. So having said that, all we have to do, distribute 5x plus 5h plus 1 minus 5x minus 1. And 5x cancels out negative 5x, positive cancels out negative 1. And you're left with 5h in the numerator. Now the h cancels out. And the limit of 5 as h approaches 0 is simply 5. And you are done. Okay? You are done, everybody. That's it. Okay? Very straightforward. Okay. We want to go to the next one, everybody. And all we have to do, write the first step. If you could write the first step, class, you're practically done. First step, namely this. So write down f prime of x is the limit as h approaches 0, fraction bar, the denominator is h. How would we write f of x plus h? Anyone? How would you write f of x plus h? If this is f of x, how would we write f of x plus h?
Over x plus h.
Beautiful. And that's it. Minus f of x is itself, 2 over x. And if we could just write this, I mean, there's really not much to it. Now it's a complex fraction we have dealt with all along. Obviously, if you plug in, you get 0 over 0 class. And dealing with a complex fraction, the easy way out was to multiply by LCD. Anybody can tell us what is the LCD? What is it that we multiply and divide by? Anyone?
H.
No. What is the LCD? What is the LCD? Look at the numerator, has 2 fractions, right? What is the LCD for those? The least common denominator.
Hx.
Say it again.
Hx.
No, it's x times x plus h. x times x plus h. The LCD, the least common denominator, is the product of the denominators class. Okay. Complex fraction simplification using this process. We have done many of these examples. Okay. All right. Let's multiply this by the first fraction. X plus h goes away, becomes 2 times x, minus, let's multiply it by the second fraction, 2 over x. X goes away, minus 2 times x plus h. And this denominator, you just write it as a product. Okay, everybody, we are not changing the denominator, we're just writing it. Believe it or not, the problem is algebra class, not calculus, because writing this, putting it into this limit format is calculus, okay, like writing this limit, but being able to write this expression, which is called the difference quotient, if you recall from pre-calculus, it's just algebra, and then being able to handle this complex fraction, it's again algebra. Everything is algebra, okay? So calculus doesn't add a lot, just a little bit, okay? So you got to be comfortable with that to be able to move on. Now, all you have to do now is simplify the numerator. So 2x minus 2x minus 2h, right? Two x and negative 2x cancel each other. And the numerator becomes simply negative 2h. Now we drop the common factor of h. Now notice what we have now. We have the limit as h approaches 0 of negative 2 is in the numerator, x times x plus h. There is nothing else we can do. All we have to do, replace the h with 0. If you replace the h with 0, what do you get? X times x. So the denominator becomes x squared. Negative 2 over x squared is the final answer, everybody. Okay. Negative 2 over x squared is the final answer. So I hope you see the importance of algebra and how much algebra is involved here. A lot of algebra. And those who have a hard time with algebra, that could drag. You really have to get comfortable with this in order to handle it. Okay. So I hope everybody's okay with that. I want to look at one more example quickly. But remember, your algebraic techniques, the most important thing when it comes to calculus. Here's the last question. Again, all of these questions can be done in a split second using the next section, okay? But let's go with the definition, f prime of x. If we can write the limit properly, practically we are done. F prime of x is the limit as h approaches 0 of this expression. Of course, the denominator is simply h, not a big deal. Let us write f of x plus h. Okay, 7 times x plus h squared plus 4 minus f of x is this thing. So I hope you see that now everything is algebra, okay? At the end, when we apply the limit is the only calculus part. First, we write the definition. To write the definition is mostly algebra. So what do you do first and foremost? You write this part, okay, as what? X squared plus 2xh plus h squared. Now you are going to multiply by 7. So you get 7x squared plus 14xh plus 7h squared. Then plus 4. Then you apply the negative, minus 7x squared minus 4. So what is this? Purely algebra. Purely algebra. 7x squared and minus 7x squared. Positive 4 and negative 4, they cancel each other. And you're left with 14xh plus 7h squared in the numerator. I hope you see all of this purely algebraic. So what happens is we can factor out the h. Remember, if I want to factor out, I can factor out 7h, but since the denominator has h, I'm going to just factor out h class, not 7h. Again, proper factoring really you have to take 7h, but I want to take the h out. So I get 14x plus 7h. So I can drop that. Okay. And now if I replace the h with 0, I have the final answer, which is 14x. And this is it, class.